Okay, recording has started. Today's session again is ratio and rate problems, and you guys have already seen the rules. So just as a quick reminder, answer buttons. Please use them. Smiley face if you understand where the answer buttons are located. Great. All right, let's go ahead and get started with a ratio problem. There you go. I'll give you about 2 minutes. Have fun. Hey guys, remember this is the GMAT. On the GMAT, you cannot leave questions blank. So if any of you have not answered this question, I'll give you about 10 or 15 more seconds, and please answer it. Thank you. The gentleman saying, I don't see the answer choices, yeah, it's data sufficiency. In these sessions, if you don't know how this particular type of problem works, we do assume that attendees of the study hall have a basic knowledge of how the problem types work, because it would be very, it would not really work if we had to explain it. So yeah, it's data sufficiency. There's still a lot of you who haven't answered the question yet, so please answer the question. Okay, let's go ahead. Julia, we don't have an answer. Mohit, Shyam, please pick an answer. Okay, here's the class results so far. There's still a couple of you who don't have answers to this. But remember that if you don't, you're not really preparing for this test, because on this test you have to answer all the problems, and you have to answer them in the order that you get them. So keep this in mind. Okay, so here's your class statistics, definitely all over the place on this one. So it's going to be some learning to do here. Let's talk about this problem. A certain movie depicted product A in 21 scenes, B in 7 scenes, C in 4 scenes, D in 3 scenes. And then you have this statement. The 4 product manufacturers paid amounts proportional to the number of scenes. Can anybody tell me what does that mean? Text box, if you guys know what that means, go ahead and type an explanation in the text box, please. What does it mean proportional to these other numbers? Yeah, if you see, you could do a ratio of products to scenes, but what's easier to think about is what Miriam is saying. The products, the payments are in the same ratios as the scenes. If you see these numbers are proportional to these other numbers, then this means that the ratios of the 2 sets of numbers are the same. So yeah, proportional to the other numbers. So the numbers are 21, 7, 4, and 3. So in this problem, this means that the ratios are the same. And so the manufacturers, assuming that manufacturer A makes product A and so on, the manufacturers paid amounts in the ratio 21 to 7 to 4 to 3. Because that's what proportional to means. It means you have the same ratio. So the question is, how do you, please don't write on the board. Thank you guys. Okay. If you want to write, then please write in the text box, not on the board. So I've just fixed that particular permission. Okay. This is text box, chat box, yeah, same thing. The question is, how do we assign variables here? Any ideas? What do you do when you have amounts in a ratio where you don't know what the amounts are, but you know what the ratio is? How many variables do we need? Let's put it that way. Text box, please go ahead and tell me in the text box, how many variables do we need? We need one variable. Yeah, if you try to use 4 variables for this, you're definitely going to be working all night. So the principle here is this. The principle is when you have a given ratio, you should not be using more than one variable. So, and in our strategy guides, there's a principle. We have a name for what you should do. You should use what we call in our strategy guides the unknown multiplier, which just means the numbers in the ratio times, I'll fix that typo in a second, times a variable, usually x. So that's supposed to be ratio, not ration. So when you have a given ratio, that's what you do. You just take the numbers in the ratio times a variable. So for instance, if you had 2 things in a ratio of 4 to 5, then you would just call them 4x and 5x. If you had 3 things in a ratio of 1 to 2 to 3, you would call them 1x, 2x, and 3x. So, therefore, what you should do in this case is manufacturer A paid 21x, manufacturer B paid 7x, manufacturer C paid 4x, and manufacturer D paid 3x. Smiley face if this makes sense. This is how you assign the variables. We haven't solved the problem yet, but give me a smiley face if you understand this. I mean, you could do this on all ratio problems where you are given a fixed ratio of, number to number. Even if it's just 2, you don't want 2 variables, you want 1 variable. It will definitely cut down on the amount of work that you have to do. So let's take this over to the next page where there's a little bit less clutter. So manufacturer A paid 21x, manufacturer B paid 7x, manufacturer C paid 4x, and manufacturer B paid 3x. So just get this up there in the corner. So now these statements are a lot more straightforward to handle if you do this. But notice again, your class answers were all over the place. Like here are the class statistics again for this problem. We were basically, it looks like we're just guessing here. I think people knew that B is wrong, but between A, C, D, and E, there's not a clear majority. It looks like people are just kind of guessing. So there's definitely, people are definitely not as comfortable with this as they should be. So statement 1, the manufacturers of product A and B together. So that means that the total of 21x and 7x is 560,000. So remember, your goal is to find how much did the manufacturer of product D pay. So we have x, if we have this equation. You don't actually have to solve for it. You can just say you can solve for x, and as soon as you realize that, you don't actually have to do it. And then once you have x, you can plug into manufacturer D, which manufacturer D we know spent 3x. So that means you're going to have a number for this, so this is sufficient. Any questions about statement 1? If you have questions about statement 1, go ahead and type them in the text box, please. Okay, statement 2, the manufacturer of product B paid 60,000 more than product C. So, question in the text box, is X the multiplier? Yeah, we call it a multiplier because that's what it does. It gets multiplied by all the numbers in the ratio. As far as why that's true, I believe the strategy guide gives an explanation for why. But this is one of those things that you definitely have to just be able to produce without necessarily going through the explanation every time. So yeah, it's a multiplier times the ratio. I'm sorry, I don't know what a ratio box is. So, all right. Statement 2, product B is 60,000 more than product C. Well, product B is 7x. And that's 60,000 more than 4x. So again, you can solve for x, and once you solve for x, you can plug into manufacturer D, which is 3x, and so this one is also sufficient. So both individual statements are sufficient, so this is D like dog. Any questions about this problem? If you have questions about this problem, please type them in the text box. Okay, one person is typing. If you don't have questions, you don't have to type no. You can just not type. So remember, the key lesson here is that if you have a given ratio in terms of numbers, no matter how, this is not just for ratios of more than two things. This is for any ratio of numbers. 21 to 7 to 4 to 3 is 21x, 7x, 4x, and 3x. If you have a 4 to 5 ratio, 4x, 5x. Important to also realize that x itself here doesn't really mean a whole lot. Like, it's just a multiplier. So in other words, to have a meaning, you have to plug it back into one of these expressions. In this problem, x doesn't really mean a whole lot, but 21x, 7x, 4x, and 3x do. So one thing that's a little bit of a conceptual stumbling block for some people is the fact that the x doesn't really mean much. But remember that the multiples of x do, even if x itself doesn't necessarily. Okay, let's move on to another problem. Remember, if any of you are latecomers, please remember to use the answer buttons that appear on the bottom right of your window, of your mini window up there. So on the left-hand side, bottom right below that list of names. Okay, let's do another problem. Try that. I'll give you some time. Have fun. Hey guys, there's still a couple of you who don't have answers to this. So please try to produce something, even if that something happens to be a random guess. Remember, when you do this, remember the GMAT doesn't allow you to not answer questions. So a couple of you still don't have answers. Please try to give something. Okay, here are your class statistics. Right there. So again, we're kind of all over the place. So let's take a look. This is a word problem, so let's review some stuff that we've learned about word problems in previous classes. So let's take a look. It's a word problem. Let me give you a basic summary. Let me find what the date of that session is in case you want a more thorough treatment of it. Organization word problems. Okay, so in this session, not the current session, but in the session from December 1st, in that Thursday's session, we learned the following principles for solving word problems. So from this session, I'll give you a basic summary of what we said about word problems in that session, and then if you want to hear or read more about it, then go watch the archived version of that session. So what we learned was when you see a word problem, you should read it twice. The first time you should ignore the math and just find out what quantities are in the problem. Under what circumstances? In other words, do they change at all? Are there any befores and afters? Are there multiple people or time frames or whatever? And then what you can do once you have done that is you can make a chart. Because you don't need any math to make a chart. You need math to fill in the chart. But all you need to make a chart is to know what are the quantities in the problem. Then, once you do that, go back and figure out the math. And you can fill in, now that you have a chart, you can fill in your chart. So let's do that with this particular problem. Smiley face if you understand the basic idea of what we're saying here. I mean, if you want more details, then you should watch that session from December 1st. But the important lesson here is that you should not try to comprehend the situation and do the math all at once. Like, that's not really a realistic thing to try to do. It's easier to first figure out what is in the problem and then go for it. So here's the deal. Let's read twice. The first read through, we should just say, what are the quantities in the problem? So can anybody tell me in the text box, what are the quantities in the problem? Under what circumstances? Not ratios yet. We're not there yet. We're not talking about ratios yet. Because ratios as math, remember you don't want to do any math until you already have the chart. So we have a January and February bill. That's not all we have, though. We're also not looking at numbers yet. Remember, no math and no specific numbers until step 2. Step 1 is to make a chart with just the quantities in it listed. So you have a January and February bill. Joshua's got it nailed here. You have a January and February bill under 2 circumstances, and Josh or anybody else, what are those circumstances? We have 1 real and 1 hypothetical. Absolutely perfect. So, Miriam, well done. So nice teamwork there. I mean, again, it's really important that you figure this out before you start working the problem. Because you can't, otherwise you're just kind of groping around. So those are the quantities in the problem. No numbers until you figure this out. No numbers or variables until you have this figured out. Because otherwise you're not going to know how to organize the problem. Like, one theme of that study hall that we cited was that the biggest problem that most people have here is just they don't organize the word problems. So before you do any math, you should have this sorted out, where you're talking about January, February, and then you have an actual, and you have a hypothetical. So you can also make this chart the other way. You could make it perpendicular if you wanted to, but that's the point. You got to have this chart. So smiley face if you understand the chart and the fact that we made the chart before we had any numbers or any math. Very important. Okay, so now let's do math. The ratio of the fuel oil bill for February, the actual fuel oil bill in February, to the month of January was 3 to 2. In the text box, everybody should be on this one. In the text box, tell me, what do you call those? If they're in a ratio of 3 to 2. What do you call two things in a ratio of 3 to 2? See if you guys are on this. You call them 3x and 2x. You do not call them x and y. You don't give them two variable names. Remember the big lesson that we learned in the last problem. If you have a ratio whose numbers are specified, then you just do those numbers times x. So in the case of this problem, 3x and 2x. So the actual fuel bill in January was 3x, and then the hypothetical, the actual fuel oil bill, sorry, that's backwards, 3x is February. February to January is 3 to 2. So again, just to review, when you have a given ratio, like here we have a given ratio of 3 to 2, do not use two variables. Just use 3x and 2x. That's what we call unknown multiplier in our strategy guide. If the fuel oil bill for February had been $40 more, so hypothetically $40 more than that, so that means we're taking a 3x and we're saying it's hypothetically $40 more than that. And then there's no change in the January bill. You're not hypothesizing any change in the bill for January. So the bill for January is still 2x. Now this is new. This is a new type of situation because now we're not defining variables anymore. Now what we're doing is we have these things are supposed to be in a ratio of 5 to 3. So what do you do in that kind of situation? If you have already existing numbers or variable expressions, then what do you set up? If we had no variables here, if we didn't have these expressions, we could just call these things 5x and 3x. But we already have variable expressions, so we don't want to do that. So these are supposed to be in that ratio 3 to 5. February to January, 5 to 3 rather. So how do you set that up? Yeah, now you set up a proportion. You don't want to set up a proportion if you are defining variables. That's very, very important. But if you have already existing numbers or already existing variable expressions, then you want to go ahead and set up a proportion. So in this case, what a proportion means is you have your 5, it's your more familiar thing. 5 over 3 is on one side of the proportion. And then you actually take the quantities that are supposed to be in the ratio and you put them in there. So in this case, you should still have one variable. Because when you define the quantities should be defined in terms of one variable, not two. So there you go. Any questions? Okay, I see someone's typing a question. So while you're typing, let's go ahead and solve that out. If you will get there, yes, you can. So absolutely, yeah, you can. So we'll get there. We'll talk about best way in a second, but it doesn't matter what the best way is. We'll have that discussion in a second. Here, if you cross multiply this thing, you get 9x plus 120 equals 10x. So that means that 1x is 120. And so then Alex's fuel oil bill for January is $240. There you go. Any questions about this approach? So yes, Miriam, we'll look at back solving in a second. It's good that you bring that up. But let's just review what we've learned about ratios so far. So what have we learned about ratios? So the first thing is that if you are defining a variable, like in other words, if you don't have any expressions yet, or numbers, then use the x unknown multiplier, x multiplier. So if you're going to define a variable, use the multiplier. So as an example of this, if you have given two quantities in a ratio of, say, 2 to 7, then you just call them 2x and 7x. Not limited to two quantities. If you're given 5 quantities in a ratio of 1 to 2 to 3 to 4 to 5, then you would just call those x, 2x, 3x, 4x, and 5x. On the other hand, we also learned if you already have numbers or variable expressions, in other words, if you don't need to define them, then what you should do is you should set up a proportion. So if you already have stuff, proportion. So for instance, from the last problem, good enough example, if you have 3x plus 40 and 2x are in a ratio, 5-to-3 ratio, because you already have those existing expressions, you don't want to redefine more variables. Instead, you just take those expressions, which you already have, and you just throw them into a proportion. So these are mutually exclusive. There's no conflict between these approaches. If you define a variable, you do that. If you don't have to define anything, you do this. One person is asking, how did we get 240? If you have this, you cross multiply, and then you do basic algebra. So, okay. Other questions? Okay, so that's how this works. Let's do one more problem. Actually, before we do one more problem, let's talk about alternative approaches to this. How else could you approach this problem? Text box. So yeah, what you should do, what you can do, is you can backsolve. What backsolve briefly means is you can work backward, starting with one of the answer choices. This is one of the most important things that you can possibly know for the quant section of this test is how to backsolve and how to do other backup methods. In fact, one thing that you should know is that backsolving can solve something like 20 or 30% of all of the problems on this whole task, all of the multiple choice questions. So if you don't know what backsolving is, or if you don't ever use it, then make sure you watch one of the other study halls. But backsolving can solve about 25 to 30% of all multiple choice problems. I mean, that's amazing. If you think about that, so much better than any textbook technique that you could learn. So this should be your #1 priority if you don't know how to do it already. So if you don't know what backsolving is, then watch the February 4th, 2010 Study Hall archive. Okay. Someone's asking what level is the problem. The answer is I don't know, and it doesn't matter. As a student, you should never, ever be concerned with the difficulty level of problems. The only people who should care about that are people who write tests. So as a student, there's no benefit to you in thinking about that. Okay, let's backsolve. Let's start with choice C. Let's try that and see how that goes. So if we plug in 360, so basically how backsolving works is you plug in one of the answer choices. You just work through the information in the problem in whatever way you can. You don't really need an advanced plan here. And then if everything checks with everything else, then you have the correct answer. And if something is inconsistent, then you have a wrong answer. So if we try 360 for January, then we have this ratio of 3:2. So that means that February is 3/2 of 360. So 3/2 of 360 is 540. If you need to solve a proportion to do that, you can. 3:2 equals 360 equals X over 360. So then if the fuel oil bill had been $40 more, this would still be 360, but then this would be 580. So 580 to 360 is not 5:3. So it's supposed to be 5:3, which means that these are incorrect, and so choice C is out. Now that you've figured out the process, it's much faster to plug in other choices because you just do exactly the same thing with all the other choices. So if we try, for instance, B, then that's 300, that's 3/2 of 300. This would still be 300, and that would be 300 plus 40. 490 to 300. It's close. It's very close. But it's not 5:3. So 500 to 300 would be. But alas, that's not what we have. And then if we tried A, then let's see what happens. This would be 240. This would be 3/2 of 240, which is 360. This stays the same. You add $40 to that. 400 to 240 is 5:3. So there you go. So, okay. Smiley face if you understand the backsolving method here, if you understand how it works. Shy might be careful with that because when you do ratios, you don't really know ascending or descending. Because, I mean, this is a problem about ratios, and if you make one of the heating bills smaller or bigger, it's not obvious how the ratios are affected. So I would watch it with that reasoning. That reasoning works on some other problems, but not so much here. Now, let's talk about a couple of comments about backsolving. The first comment is this. So 2 questions that people asked about. Backsolving. The first question is this one. Isn't that time-consuming? So there's two ways to answer this question. The first way is to point out that if you can't get the algebra to work, then what else are you going to do? I mean, you know, even if it is somewhat time-consuming, if it's your only option, then it's your only option. I mean, so make sure you don't unnecessarily restrict your options. Like, what you don't want to do is sit there and wonder how long something will take. Do not ever do that. Do not ever just sit there and wonder how long something will take. Just try it. And then if it turns out to take, you know, forever, then you can always just quit and you can just guess. The other point to make here is that it's not really very time-consuming. It's not as time-consuming as you think. Because once you figure out how to plug in one of the choices, you just follow exactly the same steps to plug in the others. So it might take you a little bit of time to figure out how to do the first back solve, but once you figure that out, the other ones are very fast because it's exactly the same process. So, like, in other words, you might have had to think for a little bit to figure out how these purple numbers worked. But then once you figured out how to do that, the blue numbers are exactly the same process, and the green numbers are also exactly the same process. So you're just grinding things through the same steps. So it's not as time-consuming as a lot of people like to think. So smiley face if this makes sense. Like, number one, even if it is time-consuming, oh well, it's kind of what you have. Secondly, it's not really very time-consuming because you're doing the same thing over and over and over again. And then, what about this? The other question that someone asked was this. Does anybody have any idea how I would respond to that? Or what should your response be to that, the best way? Totally idiotic. Wow, I actually think I'm a mean person. So far, the answers don't really capture the essence of this. I mean, what if you have no other way is, I mean, that's one valid response, yeah. I mean, again, if there's no other way that you can get to work, then what are you going to do? But also, the more important point is, it doesn't matter which way is the best, because that's only for this one particular problem. Like, in other words, like, I mean, the way that's best here may be much harder or even impossible on other problems. So, I mean, because the problems are not the same. Like, one thing that you should realize if you've been practicing for this test for a while is that problems do not look like each other. So it's very important for you to realize that, because, you know, if the problems all look the same, like if you just got the same problem with different numbers or something like that, then you could just say this is the best way and I'll just concentrate on it. The problem is that's not the reality. Like, you will not get problems that are like the ones you've seen before. They will ultimately test the same underlying concepts, but the problems will work very differently. And so the methods that work on one might not work on the other. So the consequence here is that your only goal, like literally the only goal that you have, should be to learn as many approaches as possible. It's basically like if you have one approach and someone else has two approaches, then you lose and they win. Because there you go. You should never, ever, ever think about best or easiest. Whatever. Not relevant. Because even if you find out what is best, it's only going to be best on this one problem. And for other problems, it can be anything. Smiley face if this all makes sense. Smiley face icon. Okay, if anybody has other questions, then throw them in the text box. Otherwise, we'll do one more ratio problem, then we'll do some rates. Okay, there's another ratio problem. Try that. And there you go. I think I forgot to give you a timer, so here's 1 more minute. Okay. Let's grab a couple of make sure you do that. Okay, so Anand, Palumi, remember this is the GMAT. The GMAT doesn't allow you not to answer questions, so make sure you answer everything when you practice. Here are the class statistics. So there is a clear majority answer here, and that answer happens to be wrong. So, but most of you, a majority of you picked E, and E is incorrect. So, let's take a look. Someone asked, do we use that chart approach? The chart is, we made some comments on that, but just to rehash, the chart is, the charting approach, you want to make a chart anytime you have a word problem that has lots of words. So it's not unique to a ratio situation. It's anytime you have a situation where it's explained using lots of words. The point is that you should first make a chart and then fill it in with math. I mean, it doesn't have to be, ratios. It could be anything that's got a lot of words. This, you don't have a ton of words, so it's not as important to have a chart here. But the ratio of women to children was 5 to 2. And then the number of children to the number of men was 5 to 11. So the first thing I think we can do here is decide that statement 2 is definitely not sufficient by itself. Because you have a question asking about the number of men, and there's no information about men at all in the prompt, and there's also no information at all about men in the statement 2. So there's nothing at all, like no information about men. So this means that B and D are gone. I don't think that anybody picked B or D, so good. Okay. All right. Statement 1. This means we just have ratios. So we have a ratio of 5 to 2 women to children. and we have a ratio of children to men is 5 to 11. But there's no numbers. So it's going to be impossible for you to tell the size of these numbers. This is also not going to be sufficient. Because, I mean, if you just have a bunch of ratios, then you don't have numbers. Because if things are in ratios, they can be big or they can be small. But you're not going to get numbers. So that means that A is also out. Now let's talk about how to combine the statements. So together, we do need to combine the ratios. From statement 1, we need to combine ratios. Let's talk about how to do that. So we have women to children is 5 to 2. But then we have children to men is 5 to 11. Does anybody know how to combine these ratios? Because right now you have this sort of awkward situation where this number is not the same. Like this number is a 2 in one of these, but it's a 5 in the other one. So how can we combine those? Divide them. I'm not sure, Joshua, exactly what you mean by that. Maybe you could explain. But Bahari, I also don't know what A equals B equals C is supposed to mean. Yeah, there we go. Because like the thing that you want to realize about ratios is that you can multiply them by some factor, and it's still the same ratio. So, like for instance, if a ratio is multiplied by some number, it's still the same ratio. Like for instance, the ratio 1 to 2 is the same as 2 to 4, which is what you get if you multiply it by 2, or you can multiply it by 100, etc. Like these are all the same. So what you can do to combine these ratios is multiply so that this actually matches, because then you can combine it into a single ratio. So you want to make these match each other. They don't currently match, so you want to make that happen. So, well, women and children, the least common multiple of those two is 10. So if we multiply the first one of those by 5, then that gives us 25 to 10. And then if we multiply the second one by 2, then we'll also get another 10 for children. So children to men is going to be 10 to 22. So now this matches, and so your overall ratio, women to children to men, is 25 to 10 to 22. So this is how you combine ratios. In the quick summary is you combine ratios by making common terms match. So now we know that the ratio of women to children to men is 25 to 10 to 22. Smiley face if this makes sense. Okay, I see one person is asking a question, so we'll see what that is. In the meantime, let's carry this over to the next page. Joshua says you can do that, but that's not it's not really going to help you because you want the overall ratio. Like if you do that, you're just going to get women to men. But that if you need the overall ratio, then that's not terribly helpful. So, but yes, that's valid. And in some problems, that may be all that you need to do. So that does work. So we've learned from statement 1 is that the overall ratio of women to children to men is 25 to 10 to 22. What does this mean in combination with statement 2? Like remember, these are whole numbers. So what are the smallest possible numbers of women, children, and men? Smallest possible numbers are actually 25, 10, and 22. So the only possibilities are multiples of this. You could actually have 25 women, 10 children, and 22 men. Or you could have 2 times that much. Or you could have 3 times that much, etc. So the point is that if you have whole numbers in a ratio, then the numbers must be multiples of the ratio. If they're not whole numbers, then it doesn't matter. Like if these were not people, because like women, children, and men have to be whole numbers. You can't have like 2.5 women. But if these were things that didn't have to be whole numbers, like if these were gallons of, gasoline and diesel and E85 fuel, then they could be any numbers at all. They could be, 2.5, 1, and 2.2. But because they are whole numbers, they have to be multiples of 25, 10, and 22. So when you take the 2 statements together, this is the secret, they're going to be sufficient together because the only possibility, there's only one possibility with the number of women under 30, and that's this one. So that means that you actually have to have literally 25 women, 10 children, and 22 men. This is not something that algebra will do, because algebra doesn't distinguish between whole numbers and not whole numbers. But when you get to that, if you just think that these are algebra quantities, you're going to think you can't solve the problem. But the missing logic there is that you're not realizing that you can you're not realizing that you can list out the whole numbers and just see. Okay, how did we get 25 to 10 to 22? The point is that you are trying to make these the same value, because you can't combine these ratios until you actually have the same coefficient for children. So you can multiply ratios by anything at all. So 5 to 2 is the same as 25 to 10. You just multiply it by 5. And then 5 to 11 is the same as 10 to 22 if you just double it. The point of doing that is that now both of these are 10, and we can just collapse that into a single ratio. So that's how you combine ratios. You multiply. So, oh, okay, it's men. So that means that you have this possibility. This is it. These are the numbers. Like, this means you have to have 25 women, you have to have 10 children, and you have to have 22 men. So, because there's only a single possibility. So, there are 22 men. Sarah, I hope that helps. So, once you have that, you actually have all of the numbers. Other questions? Okay, so we're going to shift topics a little bit. We're going to get a chance to do at least one rate-related problem, maybe two, but at least one. So what we've learned about ratios, we've learned how to combine ratios. We've also learned these things. We've learned if you're defining a variable, you should just use a multiplier. But if you already have stuff, you should put them into a proportion. And then we learned how to combine ratios. That's here. You make the common terms the same. Okay, let's move on to something new and different. Let's do that. Again, please answer with the buttons. Here's some time. Okay, if you need to guess, then go ahead and guess, but please do so soon. So that's Tosh, and that's it. Tosh is the only person who doesn't have an answer. So, Tosh. Okay. Let's take a look. So here's the class statistics. This one appears to be not so bad for you guys. Here are the stats. So yeah, we got a solid majority of D, but some people are also picking A, so let's go ahead and talk about it. So, all right. Did Pei take more than 2 hours to walk a distance of 10 miles along a certain trail? Okay, so there's a couple of ways that you can approach these kinds of problems, but problems about constant speed, you probably don't really need to set up a formal RTD chart for this kind of thing, because there's not a lot of complex interaction. So you probably don't need an RTD chart because there's not really any complex interaction. So making a chart here may be a little bit much. But here's a couple of approaches. First approach that you can take to this kind of thing is just reduce everything to a speed. So the question is, RTD is rate time distance chart, as described in our course materials. Okay. Did it take Pei more than 2 hours to walk a distance of 10 miles? And then notice that both of these are in kilometers. We have to convert. So we should realize that up front. We will have to convert. We're going to have to convert units because we're talking about miles in the problem, but then in both of the statements it's given in terms of kilometers. So it might be easier to just convert the miles into kilometers, because then you only have to do it once. If you're going to go kilometers to miles, you'd have to do it twice. You'd have to do both of the statements. So it's probably easier to do miles. So that's 10 miles is 16 kilometers. It's just 10 times 1.6. So the question prompt asks, did Pei take more than 2 hours to walk 16 kilometers? So 16 kilometers in 2 hours is what speed? Go ahead and tell me in the text box, the chat box. What speed would that be? It's 8 kilometers per hour, right? So that means the question is, the real question is, was Pei slower than 8 kilometers per hour? Because if it took him more time to walk the distance, then that must be slower. So statement 1 is immediate because the speed was less than 6.4 kilometers per hour. So this is definitely less than 8, definitely slower than 8. So that's sufficient. That's statement 1, sorry. I don't know what happened to the 1. If you have any questions about that, go ahead and type them in the box. Statement 2 says that it took more than 9 minutes per kilometer. So that's more than, that means slower. Because if he took longer than that much time, that means he was walking more slowly. So slower than 1 kilometer per 9 minutes. What we need to do is take minutes and do what with it? Text box. What do we have to do with 9 minutes? We have to convert it to hours. So this is slower than 1 kilometer per 9/60th of an hour. So that reduces to slower than 60/9 of an hour. So 60/9 is only like 5, is only like 6 point something. So that's also definitely less than 8. So together we have each statement individually is sufficient, and so D, like dog. So one approach you can take here is just to make everything speeds. Any questions about this approach? Go ahead and type them in the box. If not, we'll look at another approach. So let's take another approach to this. What's wrong with my screen? Okay, another approach that you can take instead of looking at speeds is you can just look at how long it would take to go that far. So, second approach, just take the question literally. In other words, see how long it would take to walk 10 miles, which is 16 kilometers. So, statement 1, an average rate of less than 6.4 kilometers per hour. So this means that after 1 hour, Pei has walked less than 6.4 kilometers. And this means that after 2 hours, he has walked less than 12.8 kilometers. So there's our answer. It will definitely take him more than 2 hours to walk 16 kilometers. Because in 16 kilometers, the most that he can cover is that. So you can just figure that out based on hours. Statement 2, 9 minutes per kilometer. So 1 kilometer takes more than 9 minutes. So 16 kilometers will take more than 16 times 9 equals 144 minutes. So this is more than 2 hours. So that's also a yes to the question. So again, we get D. That's not H, that's supposed to be D. Haha. Any questions about either of these approaches? Basically, the point I'm trying to make here is that you can kind of manipulate these things in whatever way you want. And as long as you are manipulating them in ways that are legitimate, then it'll make sense. Okay, there's no questions, no one is typing. If there are no questions, we will move on to another one that's like this. And it'll be the last problem of the day. That's this one. Go for it. I'm sorry, I think they will give you the conversions. So let me give you a little bit more time and give you, I'm going to clear out all your answers. Your answers are cleared out. They should give you, they will definitely give you 5,280 feet in 1 mile. Because they're not going to expect non-Americans to know how feet work. So they will give you that. So apologies, I'll give you 2 more minutes. Go for it. If you have answered the question, you're going to have to answer it again because I cleared out your answers. Okay, I should be wrapping up. You were definitely exposed to the problem before, so it should definitely be done. I guess that might be Clay. I don't really know how to pronounce that, but you got to answer the problem. So everyone else has. Remember, it's a GMAT. You can't not answer questions. So I think that's pronounced Clay. Go ahead and answer the question, please. Yeah, okay. There's an answer. Okay. Here are your statistics. So most people answered D, but D is incorrect. I'm not sure if you answered D just because that was how the last problem worked, but it's not D. So again, there's going to be some learning going on here. They're going to give you 5,280 feet in 1 mile. So the question here is, we have to convert units again. So which way should we convert? Well, let's look at how much work we would have to do if we converted either way. So which way to convert the units? Which way should we convert the units? So this one is in miles and hours, but this one's in feet and seconds, and then this one is also in feet and seconds. So I think we have a clear winner. I mean, we should definitely convert to feet and seconds. Because if we try to convert those into hours and miles, we'll have to do that twice. And we really don't want to work with 5,280 twice. So let's convert this to feet and seconds. So this is 6 miles per half hour, so that's 12 miles per hour. So the question is, did Carlos go more than 12 miles per hour? So we need to convert 12 miles per hour into feet per second. So unit conversions. We have covered unit conversions in the study hall. If you don't remember how to do them, then here's the study hall session that you would look at. So if you don't know what we're doing in the following work, then watch the study hall from August 11th. So if you don't understand what we are doing, then watch this archived video. Okay, so you want to convert that, so it's 12 miles per hour. And we want to convert miles into feet. So we need to put miles in the denominator and feet in the numerator so that it cancels the miles out. And then we also, that's going to kill the miles. And then we also need to kill the hours. So to kill the hours, we need to put them in the numerator. And we need to put seconds in the denominator. So then that'll kill the hours. That'll give us feet per second. So the conversions are there's 5,280 feet in 1 mile, and there are 1 hour is 3,600 seconds. So we do need to actually work out what this is. It's 12 times 5,280 over 3,600. I mean, that's kind of an annoying amount of work, but do realize that as soon as you finish this work, you're going to be totally done with the problem because the first and second terms are in terms of speeds in feet per second. So we can reduce this. 12 and 36 is 1 and 3, so this is 1 and there's 3,600 seconds in an hour, Sarah. You do have to know hours, minutes, and seconds. They will not give you that. Okay. 1 and 300, you can reduce that. And then you can also take a 0 off of these two. So it's really just 528 over 30. That's not that bad. 528 over 30. So let's see how that works. If we do division, you might be able to just do that one in your head, but if not, then we'll do a long division problem. And, okay, long division, 30 goes into 52 one time, take away 30, that gives you 22, so 228, that goes in 7 times, so it's 17 point something. And it doesn't matter. The point is that as soon as you get to this point, you can stop. So if you are actually calculating beyond this point, then you're wasting your time. So Palumi, unfortunately, you wasted some time. Joshua, you're also wasting some time. Because again, the point is these are 16 and 18. It doesn't matter what is after the 17, because that's still a number that is between these two. So don't waste your time. Like, always pay attention to what's in the problem. Pay attention. You don't need to keep working after this point. Yeah, no, it shouldn't be 17.2 because if you're, well, yeah, okay, whatever it is. It doesn't matter though, it's 17 point something. So the point is, the question is now, did Carlos go more than 17 point something miles per hour, or actually that's feet per second. So did he go more than 17 point something? Well, if we know it's more than 16, we don't know. It could still be more or less than 17 point something. So statement 1, we don't know. Could be yes or no. Statement 2, if it's less than 18, that still encompasses speeds between, it still encompasses speeds that are greater than 17 point something and speeds that are less. So same deal. And then together, it's still the same. Together, you're boxed in between 16 and 18 feet per second, but that's still not good enough. So still values that are less and greater than this. So E. The main deal, though, is you should know how to convert units, and you should also just realize that you should either express everything in terms of speed or everything in terms of some other common thing. So All right. Any quick questions we'll take? We're over time a little bit, so we gotta zip it here pretty soon. But it's not, because like we said, if you wanted to make these both miles and hours, you certainly could. It would just be more work. And if you wanted to, you could also see how long Carlos went in half an hour. So you should be able to work that out on your own. But try solving it in a couple other ways and see if you can do it. See if you can do it by making these miles and hours. It'll probably take you longer, but see if you can do it. See if you can do it by seeing how far Carlos goes in half an hour with these statements. There's going to be tons of approaches. So we just don't have time to show them now because we are already over closing time. But yeah, there's lots of ways to approach it. Sarah, if you were here earlier, difficulty levels, you don't care. As a student, difficulty levels are irrelevant. Bahari, we don't know that he went 17-something. That's a question. This is not a fact. This is a question. We don't know that. It's kind of like saying, am I over 30 years old? And this says I'm over 21, and this says I'm under 40. That's not a fact. That's a question. So make sure you keep that straight. Okay. Other questions? If not, we will close for the day. Let's see. A couple people are typing things. One person is typing things. Thanks. You're welcome. Okay, if that's it, let's go ahead and wrap it up, and thank you guys for attending. And we will meet again in 2 weeks, which would be the 2nd, I think, some date kind of like that. February something with small digits. Okay. We don't know the topics ahead of time. I actually make that decision usually a couple of hours before the session happens. So I have absolutely no idea what we will cover. If people submit it, then we might cover it. But remember, Shyam, you've got to submit something that we already haven't covered. So where can you find the archives? You go to the Thursdays with Ron page and you scroll down. That's where you find them. Okay. You go to the Thursdays page, the same page where you signed up for this session, and you scroll down. And that's where you'll find them. Shyam, if you want to submit critical reasoning, feel free to submit it, but go through the archives first and make sure we haven't covered the topic already, because most major critical reasoning problem types we have covered. So if you're going to submit it, make sure you submit some sort of new angle on it or some sort of aspect that we have not yet covered. Because if you just submit something like assumptions, then we won't do it because we already had a session on that. Okay, let's quit it. Looks like a couple of people have questions. I'll wait until you finish typing. I'm going to turn off the recording at this point. So